Hello, Math 141. Suppose I have 2 to the power of x minus 10 times 2 to the power of negative x plus 3 equals 0. The first thing I need to do is I need to remind myself that this is the same as 2 to the power of x minus 10 over 2 to the power of x. Remember, negative exponents are negative numbers, are fractions. So I have a plus 3 here equals 0. And now that I have this, I can easily see that my least common denominator is 2 to the power of x. So I'm going to go ahead and multiply both sides of this equation by 2 to the power of x. So the first part, this 2 to the x times 2 to the power of x is 2 to the power of 2x. Remember, we keep the base and we add the exponent. Minus 10 plus 3 times 2 to the power of x, all that equals 0. It would be nice at this point if we just go ahead and put this in order from the highest power, 2 to the 2x, to the lowest, plus 3, 2 to the power of x, and then minus 10 equals 0. Now, I'm going to go ahead and factor this. Let me go to the next page. I have 2 to the power of 2x plus 3 times 2 to the power of x minus 10 equals 0. So here I can factor this to 2x plus 5 and 2x minus 2 equals 0. Two numbers that added up to 3 and multiplied to negative 10. So suppose you're kind of rusty and you kind of, with factoring, that is, you want, you look at this and you say, I really have difficulty factoring this. What can I do? Well, here's what you can do. Let me go ahead and just erase this. You can use some sort of substitution. Let's say you can say, let u equals 2 to the power of x. If you score both sides of this equation, then you have u squared equals 2 to the power of x to the second power. And that's the same as saying u squared equals, here's my base, x times 2 is 2x. Now using these, I can substitute. Instead of 2 to the power of 2x, I have u to the second plus 3 times u minus 10 equals 0. And that factors out to u plus 5, u minus 2 equals 0. And remembering that u was in fact 2 to the power of x plus 5, 2 to the power of x minus 2 equals 0. So notice that if you don't, if you are not very well practiced with your factoring, you still can use a substitution. So let's continue from here using zero product property. I'm going to set this equal to 0, and I'm going to set this equal to 0. Going to next page, so 2x plus 5, 2 to the power of x plus 5 equals 0, and 2 to the power of x minus 2 equals 0. So this gives me 2 to the power of x equals negative 5, and 2 to the power of x equals positive 2. Well, this one produces no real solution. But here, 2 to the power of x equals 2, I can just simply take log base 2 of both sides. Okay, so now I have x equals log base 2 of 2, and I know log base 2 of 2 is 1, because 2 to the power of 1 equals 2. Let's do one more similar to this. Suppose I have e, start with a black color, e to the power of x minus 12 times e to the minus x minus 1 equals 0. So I'm going to go ahead and remind myself that this is the same as e to the x minus 12 over e to the x minus 1 equals 0. And now I can multiply both sides by LCD, e to the x. That produces e to the 2x minus 12 minus e to the x equals 0. If I rearrange that, I get e to the 2x minus e to the x minus 12 equals 0. And now I can factor these to uh, e to the x. I need two numbers that add up to negative 12 multiplied to negative 1. How about minus 4 and e to the x plus 3 equals 0. Remember, if you have difficulty factoring this the way it is, you can use a u substitution. Let me go to the next page and do it. So suppose I am at this point that I have e to the 2x minus e to the x minus 12 equals 0. I'm going to say let u equal e to the x, then u to the second equals e to the 2x. Because e to the x times e to the x is e, you keep the base and you add the exponent. And so now we can rewrite this as u to the second minus u minus 12 equals 0, u minus 4, u plus 3 equals 0. And remember, u, we said that is e to the x. So e to the x minus 4 equals 0, and e to the x plus 3 equals 0. Add 4 to both sides gives me e to the x equals 4. Subtract 3 from both sides, e to the x equals negative 3. And right here, I know there is no real solution. No real solution. And here's the only thing I can work with. I can take natural log of both sides, and that result x equals natural log of 4. X equals natural log of 4. Well, I hope you enjoyed these two examples solving exponential equations involving negative exponent. Thank you.